Hi, and welcome to FOSDEM Fringe for AI Plumbers, edition number 2. I'm Felix from Echo, and I'm sitting here with
Ben from Hugging Face.
Ben. Just did a really awesome talk earlier today on Kernelize and that really cool project. But I think one of the cool things we want to do is engineers are people, right? So what kind of got you, Ben, into writing high-performance kernels?
Okay, yeah, interesting question. I don't write high-performance kernels. I am a user of high-performance kernels. So I train machine learning models, mainly in a post-training setting. But most of all, I work in the advocacy team at Hugging Face. So I'm not a daily trainer or builder of models. I use them on the side for specific use cases, for specific domains. And in that, I'm a huge beneficiary of optimized kernels like Flash Attention 3 and 4, etc. And I mainly use those on single instances. I don't have a kind of mega cluster that I use. I'm usually using them to kind of reduce costs or save me time. And up until recently, they've taken a number of hours to install from source. So Hugging Face has released the Kernels Hub, a library, a client library, and a building library to go with that. And with that, we can basically get those kernels in a couple of seconds on most instances, and we can save ourselves a lot of time. And so yeah, I'm a beneficiary of that work, basically.
That's really cool. So then in terms of using the models themselves, how are there any ideas around how do I use models to help me do the kernel work? Or is this still a very human process in terms of supplying those kernels to the community?
So that's an interesting question. Just last week, actually, we wrote a blog post. We collaborated with some engineers from the diffusers team, from the kernels team, and from the agentic team. And we got Claude code to generate and write kernels. To be honest, when we first did this, Claude was extremely bad. Even Opus 4.5 really struggled at this use case. It took us a number of hours of back and forth to get Opus to do this. And so we used a skill.md, which is a new format that most agentic libraries are working with now. So you define a skills.md, you say, this is how you write kernels. You define references files with all the best practices. And then you also give example scripts of how you do it.
Super cool.
And Claude was able to get through it. And it could write kernels. We wrote a kernel for diffusers and H100, which was really nice. I think it was about 50% faster than the baseline. But what was really cool is that we also generated a set of evals for it and test set. So we measured and benchmarked the kernel. So we said, okay, Claude says he did it, but they said they did it. How much faster is it? Is it actually faster? Does it actually work? So okay, then we had this base setup. And then with that skill, we took it over to other models. So this was this kind of Robin Hood moment where we took it over to first of all to GPT 5.2 to benchmark that. And what we found was the skill doesn't just translate. So you can't just say, okay, great, Claude did it, now they all do it. Actually, we saw that some models didn't really even get that much better. So GPT 5.2 didn't benefit so much from the skill as Claude did. But open weight models like Kimi 2.5 got way better, and they also used a lot less tokens. So in the baseline setting, they were doing it, but they were really consuming tokens in order to do it, right? They're on this kind of Ralph loop. But when we gave it the skill, it was okay, it's just going straight to it and it's doing it. So yeah, that's a bit of a tangent into the agentic world.
That's super cool. That's super cool. Being able to bring that, because the whole point of Hugging Face I see is how do I go and expose so much more of how the models work? Present so many different models. What's the infrastructure behind it? How do I serve that? How do I empower the people working on all aspects of the flow? And integrating agents is the big thing right now. And on the performance side, it's fascinating because what happened this week was the big Anthropic performance challenge, right?
Yeah.
Can you beat this many cycles? Can you beat Claude? And we've seen a lot of people beat Claude, but now we're also at the point where, as a performance, my background is performance engineering.
Right.
How do I go and use these kernels and generate these kernels? It's wait, I don't have to worry about this stuff? I can let Claude or Kimi K2.5, incredible model in the open source community. I can use 5.2 and expose that. So then the question for me becomes, how does the kernelized community, as part of Hugging Face, then go and look at which kernels it makes sense to bring in? And how do you approach that from a developer empowerment standpoint of, we're gonna have a lot of kernels, how do I empower the new developers who haven't had that start? in doing the low-level kernel design to still be contributing to the community?
Yeah, so that's really the most important question for us. So if you look at optimized kernels and you see new model releases and kind of new hardware releases, typically what you'll see is like a really nice pairing at the top of that. The latest models are paired to the latest hardware, and you'll see quite nice optimized kernels that are really well integrated. But generally, as you go down the spectrum of hardware into the older and cheaper categories, you don't see the same support. And it's actually, that's the area where most of the community is sitting, most of us are sitting, right? People that just want to run a model, just want to run it locally on hardware that we can actually afford, or these kind of things, old hardware that we don't want to necessarily replace. And so inside the kernels community, you'll see a lot of support for NVIDIA, AMD, Intel hardware as it comes out, growing and growing, which is great for users of that hardware. But building off of that, we can see that the kernels community goes into like older AMD hardware or older NVIDIA hardware. We're getting things to run on T4s and things like this. So it's like, okay, now we've got it on Colab for free, and that's a huge unlock for people, right? Colab is like the big unlock in the community, because it's like, now I can do whatever it is for free, just on the free tier, and it's really cool.
That's awesome. That's really, really cool. And then from there, that kind of begs the question, as we see the models getting better at generating these kernels and people working on these kernels, and we see this sort of give and take and working together, do you think that we're going to be able to generate more kernels for that older hardware to help those users that are limited or only have access to that older, cheaper hardware?
Yes.
How does that change over time?
I think, in essence, the biggest part of the problem is probably not the agents being able to do it, but more the infrastructure around the community. So the kernels hub, having hermetically sealed, reproducible kernels, because in many ways, it's probably possible now to get an agent to write kernels based off Flash Attention 3 in that similar format. But it doesn't necessarily mean that they can be shared widely across the community, right? It's the kernels libraries contribution that unlocks the community to get access to that. So I would say, yeah, the agents definitely kind of supercharge it, but without the kernels hub, there really wouldn't be any usage layer for those kernels that the agents generate.
Yeah.
That would be my expectation.
Okay, and then you also have a huge diversity of hardware you're supporting, right, as you mentioned. So with that, is there an effort to make sure, like, yeah, that I can't reuse this exact optimized kernel, but this quantization of this model is using similar sub-quantization techniques to fit on this specific hardware, and I can take those learnings and actually expose those learnings to the user? Because to your point, a lot of these techniques you can beg, borrow, steal from different models, different optimizations of how do I go and translate this and make that information available to normal everyday developers, right?
Yeah, so the kernels hub is extremely educational because of the fact that it's declarative and standardized. So you can go to a kernel on the hub and you can go to firstly to the README, and the README is generated and it will have a standardized set of build options that it's built for. Then you can go to the build.toml and you can look through the build.toml and say, okay, this works for this hardware in this kind of situation. And then from there, you can go to transformers and you can look at the modular declaration of a model, so like GPT OSS, and you can say, okay, this is where that kernel was used for that model. And then from there, you can go to the modeling.py and you can look at how that ends up as modeling code. And you can see other models that are potentially used within this model and how they use kernels. So we kind of like unlock the single source of truth from this one place, right, from the kernel, so that it's tethered together all the way back through the ecosystem, basically.
Speaking of that ecosystem, how does someone get involved?
So if you want to get involved with Hugging Face, the best way really is just to start pushing models to the hub or pulling them and just trying to use them. If you want to contribute to a library like Kernels, the best thing to do is to go to the GitHub repo and the Hugging Face org. So to join and follow the Hugging Face org, if you do that, you'll get updates about new things that arrive. If you go to the GitHub repo, you'll find good first issues and you can start to build yourself there. And probably just to try kernels. Like, it's one line of code, you can stick it in Colab, and you'll just kind of see the gains. Like, just feel it. So I'd say.
That's awesome. Well, hopefully a lot of people get involved. I'm looking forward to hearing more. Awesome talk earlier today.
But thanks
you so much, Ben.
Thanks.
Thanks so much, everybody.
Thank you.